Okay. So we're doing our second to last set of notes on the acid and base units. Your acid base test will be this Friday. I'll do this one today, next one tomorrow, and then review and test. So we are kind of getting close to the end. The water test and the acid base test were pretty short, so these are little kind of mini units. Okay, so a lot of this top part, you should have learned from Friday's lab. I am going to grade Friday's lab, so make sure if you have not done the pH virtual lab, you do it. And this will kind of review what we're looking at right here. So pH is a scale used to relate the strengths of an acidic and basic solutions. So how it works is the pH range from 0 to 14. You should know, we've kind of already mentioned that already. But 7 is neutral, meaning it's not acidic or basic. And the more it goes this way, the more acidic it gets. The more it goes this way, the more basic it gets. So the further away from 7 the pH value gets, the more acidic it gets if it's getting low, or the more basic it's getting, the number's getting higher, okay? Now, what it means in an acidic solution, remember acidic solutions have the H, they're like HCl, they start with the letter H, we've learned that in our naming unit, and they have H plus ions in them, okay? So that's the more H plus ions they have, the more acidic the solution is. So if I have a solution and there's more, see that more sign, there's more H plus ions than there is OH, because OH is what makes something a base. Remember, a base would be like NaOH, that's sodium hydroxide. Things that end in OH are a base. So if there's more H plus ions than the OH, then it's more acidic. If there's more OH, negative ions than the H plus, then it's more basic. Okay, so that's how it's measured, is how much H plus ions are in it versus how much OH ions are in it. Okay, now we have this little formula here, and really we're going to keep it pretty simplified, but this is the formula that we won't really need to use, but it's what you refer back to know this thing works. So pH, so this is the pH scale, so the pH of something is based on negative log times the value of H plus ions in it. Okay, so I do negative log the number of H plus ions in it, and that will give me the pH value. The more there is in there, then the higher the acidity, so the lower the pH, the less there is in there, the higher the pH will be, so the more basic. Now, how I can use it is if the problem is set up in scientific notation, like this one, if it's set up already in scientific notation with something being times 10 to, or 1, it has to be 1. If it is 1 times 10 to the something negative value, whatever the exponent is the pH, okay? So if they say the H plus concentration, it doesn't have to say that. It says OH is different. If it says the H plus concentration is 1 times 10 to the negative something power, that exponent is the pH, but it's not negative. pH is never negative. See the values up here, it's 0 to 14, so it's not negative. So I just leave off that negative number. So in this case, the pH is 3, not negative 3, it equals 3, okay? So it's 3. So then all I had to do was literally look at that exponent, and that's the answer. Now, if they give you a number like this, and they say the H plus concentration is 0.0000, all these zeros in front, all I need to do is turn it into scientific notation, and as soon as I've turned it into scientific notation, then whatever the exponent is my pH. Now let's review. We did this at the beginning of the year. How do I turn this into scientific notation? I hop. Of course, it's not really working. My board is like not hopping the right spots. Okay, so I'm just gonna imagine I'm hopping. I'm just gonna do dots. So 1, 2, 3, 4, 5, 6. It's gonna hop 6 times because you want that dot to be in front of one number that is not a 0. So it's going to end up looking like I hopped it in front of the 1, which means I hopped it 1, 2, 3, 4, 5, 6 times. Be times 10 to the negative 6, because this negative is telling me if I wanted this number to go back to what it originally was, I go this way to make it smaller. Okay, so it's a negative 6. So if we have it set up like this, just like this was, 1 times 10 to the negative something, whatever number is in that exponent is the pH. So the pH is 6, okay? Now let's think about what those are, those acids or bases. Well, anything under a 7 is an acid. So this is a 3 and a 6. So these are both acids based on their pH. They both have more H plus ions in them than they do OH ions, and they are acidic. Okay, let's do the next time. So it says, what is the H plus concentration of a solution that has a pH of 9? Well, this is just backwards of what we just did. So if I know the pH now, it writes on top of it. I'm trying to underline it, and like my board's never calibrated enough, so it's not underneath it. Okay, so now it's just the backwards. If I know it's 9, well, then I do 1 times 10 to the negative 9. There you go. Because remember, we just look at that exponent just like we did in the one previously, and just 1 times 10 to the negative, whatever the pH is. Now, the key thing to make sure you know you're doing this right is H plus goes with pH. So if they don't say that, there's going to be an extra step. But if it says, what's the H plus concentration of a pH, then it's literally that simple. If they say, what's the pH of H plus concentration, like these two, it's literally that simple. If they ask something else, let's scroll down and see it get just a little bit more complicated. Dang it. Won't ever scroll down anymore. I don't know why my board just gets worse and worse. Okay. All right, so when it gets a little more complicated, is you can also do it. Okay. So you could have this formula, which instead of being pH, it's POH. We're like, okay, what's POH? Well, pH is all we really talk about in life. That's the pH scale. It means an acid or base. But really, because pH is about H plus concentration, so making something more acidic, you could also think about it as POH. Why is it? Well, right up here. There we go. A POH would be like if I have that concentration, make it more basic. So you really can use both information. Now, if I have the pH and the POH, then I just have to subtract out 14. This is making me so mad with not writing in the right spot at all. Let me see if I will calibrate it. It usually doesn't help anymore, but I'm going to try. Okay. So if I have the pH of something and I want to find the POH, or if I have the POH, I want to find the pH, I just subtract it off. So like, let's say I know the pH of my solution is 7. So what's the POH value? Well, if you know it equals 14, wow, that is not what that equals at all. If you know it equals 14, and to find the missing value, you just subtract off the 7, So now my POH would be 7 too. So you literally just subtract off the one that you don't have, and then you can find the other value. And this one works the same way as the one above it worked. If it's talking about OH, then whatever the exponent is would be like 1 times 10 to the negative 9. Well, then that is the POH now. So whatever exponent is up there is the POH. You just have to make sure they match, that this one is OH and this one is also OH. If they're not matching, then it doesn't work like that. Okay, so let's practice that. So it says, if I have the OH concentration, and it's 1 times 10 to the negative 4, what is the POH? Well, what I just said, it works the same way as what we were just doing. As long as they're both OH, then it's just that number up there. So the POH is 4. Well, how do I find the pH then? Because that's what I really need to know if something is an acid or base. I need to know what is its pH. So if its POH is 4, and I put it in this formula, it'd be, we don't know this one, so let's put in a missing, just put an M for missing. We have M plus 4 equals 14. Well, how do I figure out what that N is? I subtract off the 4, and that gives me 10. So my pH value is 10. Okay? That's how you work those. All right, now this is like the old one. It says pH, so it's pH. What is the H plus concentration? So those go together, H and H. H, pH, H concentration. So the concentration is the 1 times 10 thing. So 1 times 10 to the negative 6. Because they go together. H and pH are both pHs. If it says I have the pH of 5 though, what is the OH concentration? So this is the 1 times 10 to the negative something. Here's the problem. These don't match. pH, OH. Those don't go together. So basically what I'm going to have to do in this case is I'm going to have to find the pOH first. So if I know the pH of something is 5 plus pOH equals 14, well, I subtract off the 5, and that will tell me what my pOH is. So 14 minus 5 is 9. So my pOH, write that here. So my pOH is 9. Well, if it's 9, then what's my OH concentration? It'll be 1 times 10 to the negative 9. Because they always, so now they go together. This is OH, this is OH, they go together. It's just 1 times 10 to the negative 9. Okay? I realized I didn't answer this one, so let's answer it. So this is, the H plus concentration is 1 times 10 to the negative 6. So it says, what's the OH concentration? Well, when it's talking about the concentrations, it's 1 times 10 to the negative something. If this is 6, remember 6 is the pH, so I have 6 plus something equals 14. One subtract off the 6, subtract off the 6, and that gives me 8. Yes. So this would be a pOH of 8. I wrote higher than I wanted to, but negative 8. There we go. Okay. All right. Last one down here. The last type. Just move this out of the way. Oh no. How do I do that? Do it again. Here. I just hit the word wrong. That happened. Okay. If I have the H plus concentration of this, okay, so 1 times 10 to the negative 2, what is the pOH? Okay, you're looking. This H plus, this pOH don't go together. They don't match. So I need to get my H plus concentration into pH. So if H plus concentration is 1 times 10 to the negative 2, then my pH, because those together, H and H, is 2. Well, what's my pOH then? Well, 2 plus something equals 14. So what plus 2 equals 14? 12. So my pOH is 12. Okay? So you kind of have to go back and forth between using those two things. All right, so down here, it's a little bit more of like understanding what an acid is. So think about the impact of drinking sodas on your teeth. Do you think soda is more acidic or more basic? Now, mostly it's like you should know because a base is mostly like soap. So it's like cleaning products are usually basic. Soda is definitely not cleaning your teeth. So it's going to be more acidic. Now, I looked it up earlier. What is the pH of a soda? And it's about 2 to 3. It's about 2 to 3 pH. So that is acidic. Based on this value, is soda an acid or base? So I just said it. So it's an acid because its pH is below a 7. What color would a litmus paper be in solution with a pH of 4? Now, if you had done your lab on Friday, you should know this, that litmus paper turns red, or stays red, depending on what it was originally, acid, and goes blue for a base, okay? So if this is a pH of 4, that's less than 7, so it's an acid, so it should go red. For a pH of 9, that's above a 7, so it should be basic, so the paper should be blue. So remember, litmus paper is just it's an acid-base indicator. What color it turns should tell you if it's an acid or a base. Acids are red, bases are blue. Kind of remember because bases start with B and so does blue. All right, done with notes for today. How to calculate pH from different values.